Well, dear students, now I will be telling some questions from competitive exam asked in competitive exam from Bohr theory of atom. So now questions are simple, but few need a little mathematics. So here first question is there in alpha scattering experiment when an alpha particle of mass m moving with velocity v bombards a heavy nucleus of charge Zd. Here is the nucleus of charge Zd, alpha particle of mass m moving with velocity v is incident. Then the distance of closest approach from the nucleus depends A part, A option है 1 by m, B option 1 upon root m, and C option 1 upon m square, or D option m. Alpha particle of mass m moving with velocity v, when is bombarded on actually element having mass number charge Zd, then what will happen actually when it approaches here? Kinetic energy converted into potential energy. Charge of alpha particle 2e, alpha particle, alpha particle क्या होता है? It is 2He4 in fact. It has 2 charge, 2e. So that way half mv square is equal to 1 upon 4 pi epsilon 0 और 2Ze square upon r होगा, where r is the distance of closest approach. So here r is equal to 1 upon 4 pi epsilon 0 और ये 4Ze square upon mv square. v फिक्स है तो here r proportional to 1 by m. तो first answer is there. I think it will be very clear to you. Second question here. This question was asked in NEET 2016. Last question जो अभी था 2016 NEET 2016. Now question 2. Hydrogen atom in ground state absorb 10.2 electron volt of energy. The orbital angular momentum of electron increases. Hydrogen atom in ground state. Ground state means lower in the state. In first orbit. Absorbs photon of energy 10.2 electron volt. So when it will absorb energy, it will go to high energy state. तो कह रहा कि इस एंगुलर मोमेंटम विल बी ए पार्ट है h upon 2 pi, b part 2h upon 2 pi, and c option is 3h upon 2 pi, and d option is there 4h upon 2 pi. Actually, from Bohr theory, you know energy of electron in 13.6 upon n square इलेक्ट्रॉन वोल्ट हाइड्रोजन एटम के लिए minus 13.6 इलेक्ट्रॉन वोल्ट E1 E2 minus by 3.4. Here E2 minus E1 directly come 10.2 electron volt. So if electron in ground state absorb go to second state, यानी कि n equal to 2 में चला गया. From second postulate MVNRN equal to h upon 2 pi nh upon 2 pi. This is angular momentum. वही पूछा है तो angular momentum L equal to nh upon 2 pi. Since electron has gone to second orbit, it is orbit 2, so it is 2h upon 2 pi. B option is correct. तो थोड़ा we have to learn the basics. Actually, it is not so difficult to complete any exam. Problem is in the basic. Problem is that we are unable to understand the whole syllabus. We don't spare time for studies. You have to work yourself. Now, question number 3 is little difficult for you, especially for bio students. It may create trouble. Electric potential between a proton and electron V equal to V0 log base E R upon R0. Potential means potential difference between electron and proton is this, where R0 constant. Assuming Bohr model to be applicable, the variation of radius Rn with principal quantum number, option A, Rn proportional to n. B option, Rn proportional to 1 upon n. C option, Rn proportional to n square, and D option, Rn 1 upon n square. So here you need to attempt this question. Actually, the force between electron proton is electrostatic force, and electrostatic force is conservative force. In class 11, it is taught that conservative force is equal to negative of the gradient of potential energy, or we can write F magnitude of this force is equal to D upon dr upon U. U means potential energy, and potential electron will be here D upon dr of EV. This V, potential difference multiply charge की potential energy, or it is D upon dr of EV equal to V0 log base E R upon R0. Now mathematics students really understand how to differentiate this. modulus F is equal to EV0 d upon dr of log base E r upon r0. It is equal to EV0 or into 1 upon r0 or into r0 also. Differential of log x d upon dx of log x is equal to 1 upon x. So that way it is this, or it comes out to be EV0 upon R. F is equal to this, F is equal to EV0 upon R. But the force between the electron proton is balanced by centripetal force. This force also is equal to what, F is equal to mv square by r. So mv square by r is equal to EV0 upon r. R cancel, so v is equal to under root EV0 upon m. Here EV0 or m all are constant value. So v is a constant value. I hope you are getting my point. From second postulate of Bohr theory, MVRN equal to NH. क्योंकि हमसे पूछा गया कि Rn, how does Rn depend on principal quantum number? So here Rn is equal to NH upon m into v, and v is a constant value. H constant, this v constant, m constant. So R goes to n. So here option A is correct. Option A is correct. Actually, we have to go in deep also. Nothing else we have to apply theory. So we must remember basic theory of our physics. Actually, little problem of mathematics by students, and this was asked in JE 2003. This question was asked in JE 2003. When I see the reaction of students when they listen the news that this particular topic is deleted from the syllabus, they feel very happy. But they don't know how much they are losing. Actually, I don't understand why our educationists are making us not to think. Imagination, knowledge बहुत जरूरी है. Now question number 4. A good question and has been asked in again JE 2003. From the chapter you will get questions certainly which are easy. I feel all these chapters easier than the part of electrostatic and mechanics of class 11. Here question is like this. In atom 100 Fm 215. If this atom follows Bohr's model and the radius of fifth orbit of this atom, fifth orbit is P times the Bohr radius. Then what is P? So P equal to दिया है उन्हें A 100, B 200, C 4 and D 1/4. These are options. अब थोड़ा सा तो हमें याद करना होगा. रेडियस बोर ऑर्बिट कौन सा होता है? फर्स्ट ऑर्बिट ऑफ एच एटम. नाउ फ्रॉम बोर मॉडल यू नो Rn is equal to epsilon 0 n square h square upon pi z e square m. देखो भाई इतना तो हमें, if we are going to get something different from others, so we have to be different person. We have to get more and more knowledge. Z pi z e square m. Z is a number. Now what is this 100? I will be telling you if I write ZXA, X the name of element, Z atom number, A mass number. So 100 is the Z here for this atom. For Bohr orbit R0, यानी कि R1 कह लीजिए इसको. Epsilon 0 and 1 h square upon pi 1 e square m. For this atom, radius of fifth orbit of this atom, यानी कि here you have to use n5, epsilon 0 into 25 into h square upon pi into z 100 into e square m. What is this? 1/4 epsilon 0 h square upon pi e square m. It is R1. So R equal to this R1/4. So this R equal to P. So PR1 equal to R1/4. So P equal to 1/4. Simple answer. I hope you are enjoying with me. But I am noticing here that viewers are not taking interest in my videos, but I don't understand what to do. Actually, many people ask me the marketing for this, but I will not go that way. If I am doing something, if someone wants to get advantage of it, then it's okay. Now, next question, simple one. In which of the following atoms and ions will the radius of smallest orbit minimum? Smallest orbit means first orbit. तो कौन कौन है? नंबर 1 A हाइड्रोजन. इसमें लिखा है, नाम लिखा. B deuterium atom, not ion. And C singly ionized helium, D doubly ionized lithium. doubly ionized lithium. क्वेश्चन क्या है? In which of the following atoms or ions will the radius of smallest orbit minimum? यानी कि फर्स्ट ऑर्बिट किसका छोटा होगा? अगेन आई टोल्ड यू Rn is equal to epsilon 0 n square h square upon pi z e square m. For hydrogen, first orbit for hydrogen, n1 z1 epsilon 0 h square upon pi e square m. Deuterium also hydrogen atom 1h2 फोर सेम होगा, ये He के लिए भी यही होगा. Ionized helium, it has one electron but mass atom number 2 and सबका वन ही है. for He first orbit epsilon 0 h square upon 2 pi e square m. For lithium, doubly ionized, lithium has atom number 3 Li6 केस को, तो it will be epsilon 0 h square upon 3 pi e square m. So naturally lithium has the least value. It is minimum for lithium, doubly ionized lithium. Yes. So I hope these 5 questions will be awakening you. One more question here is there, simple one. The ratio of speed of electron in ground state of hydrogen atom to the speed of light in vacuum. Speed of hydrogen atom in ground state in first orbit. You must remember that speed v of atom electron is 2.2 in 10 to the power 6 simply, or you can write nearly 2 in 10 to the power 6. Speed of light c in vacuum 3 in 10 to the power 8. So you are asked ratio किसका? Speed of electron v upon c 2 into 10 to the power 6 upon 3 into 10 to the power 8. So it is 1 upon 3 by 2 1.5 10 to the power 2. अब ये ऑप्शन तो नहीं है. Ratio of speed of electron in ground state hydrogen atom to the speed of vacuum. मेरा आंसर 2.2 लेकर आया हूँ मैं. 2.2 लूँगा तो यहाँ पर फिर ये क्या होगा? 22 upon 30 into 100. 30 upon 22. 1 जा 8.03. yes हाँ. तो ऑप्शन इज 1 upon 137. It will come out 1 upon 137. So this way you can solve many questions. I will be telling you later in other videos. And please like the videos, share the videos, and if you have not subscribed, subscribe the videos. Subscribe my channel also.